The Materials World modules are hands-on, inquiry and design-based curriculum units for middle and high school students. Using principles from the interdisciplinary fields of materials science and nanotechnology, this curriculum aligns well with STEM objectives, engages students, and adds relevance to existing curriculum.
Hi, I'm Ken Turner. I'm a chemistry teacher at Schaumburg High School in Schaumburg, Illinois. And I'd like to show you something that MWM out of Northwestern University has come up with. It's a fantastic new group of activities, and the one that I'm sharing with you today is called Composites. The Composite Module is one of my favorites. It's easy to do, it's great for the students, it's innovative, it uses new materials, it's got applications to every day, and it gets them into the inquiry of science, it gets them into the doing of science. When I start this project, this group of activities, I like to start with a hook, something that grabs the student's attention. The hook that I use is to bring out a couple of discs, and you can tell the students they're discs of ice. And these discs of ice, have them examine them, and then test them for strength. Now, you don't have to tell them how to test them for strength. Just let them come up with it. How will they test these for strength, and what's the difference here? So I'll test this one first. Now I'll test this one. This one's a little bit harder to test for strength. And they will find the same thing. They're going to find the same thing. And Mr. Turner, what is it that's different about this one? I can see it even looks different. When I look at it, it looks different. It feels a little different. What did you do different to this ice? And I say, well, of course, we reinforced it. We reinforced it with some new space-age, high-tech, really strong material. We reinforced it with toilet paper. And the students see this is the hook. They're going, how can you make something so strong just by putting ice and toilet paper together? How does this soft, fluffy material end up being so strong with this composite, with this ice? And that gets them into it. And then you can go about teaching the science of composites. And the way I like to do it then is I'll start using the word composite, and somebody asks me, well, what does a composite mean? Well, I like to say a composite means you've got at least two dissimilar materials joined. All right? In this case, it was the ice and the toilet paper. From this, you can show them maybe even just a short definition of, from the pages of the manual, you can show them the particulate composite, the laminar composite, and the fiber reinforced composite. And from that, you can start listing, well, what are some of the examples of composites? And then maybe they'll do a composite search. Maybe you'll ask them to come up with some composites that they might have experienced that might have a look of something like that. You don't have to give them much more direction than that. Even if they make mistakes in coming back to you, you can leave this for an overnight assignment. Even if they come back with some mistakes, it's okay, because you can go over those mistakes in the discussion that follows. But the thing that should come out of the discussion is how pervasive these composites are. They're everywhere. If they look and they see a concrete street or an asphalt street, they'll see the materials embedded in the concrete or reinforced concrete. They can't drive down the street without having composite materials on their car. They use sports equipment. Kids, every kid has a favorite sport. They'll see the racket ball and the racket for a tennis racket or a badminton racket or a racquetball racket. The shoes that they run in, the shoes that they walk in, the shoes they buy just for being at school or going to where they hang out. Archery. Completely different bow materials now, completely different ability of the bow. The golf shaft. This is what the shaft of a golf club looks like if you peel away the top layer. And it's just sheets of graphite like this. And it's just these sheets, these plies, woven together in different patterns to determine the strength and the rigidity, the flexibility. They can make, with composite materials, they can make cardboard so strong you can walk on it. They make your bike helmets. They make football pads. They make the roller skates, the roller blades, skateboards. This, look at this. All the weight is down here at the head of the mallet. All right. All the weight's down here. This whole handle is a composite material. It's extremely lightweight, but stronger than the wood they used to make it out of. So it's lightweight, it's rigid, it's strong, the properties you'd want for that. Fishing rods. The poles of the fishing rods are now composite materials. You can hardly look anywhere in the sporting world and not see it. They attribute some of the records of the Olympic pole vault to the new materials of the pole that they're using. Space-age materials being used by NASA, both in their testing and their actual vehicles. The shuttle and the propulsion are full of composite materials. They have to make them as strong and as light as possible, and that is done through these composites. Bondo for your car is a composite material. The airline industry, you can see where they'd have to minimize their weight and maximize the strength. They're everywhere, and the students are going to see this. The students are going to see that the composites are everywhere. After they see how pervasive these composites are, there's many other activities in the module. There's experimentation with the laminates and how strong and where you reinforce the laminate and how the reinforcement might make it more strong or more rigid or less flexible. But early into the set of activities, I usually like to tell the students about an end project. All right? I tell them that eventually they're going to use the knowledge to design a fishing pole. They're going to design a fishing pole. They're going to design a prototype of a fishing pole, just like they would in industry. You design the prototype first. Their design of the fishing pole is going to revolve around the dimensions of a straw. And they're going to be put in teams, and they're going to use the scientific method. They're going to have controls. They're going to have variables. And they're going to come up with a better fishing pole. And then they're going to present it to class. And they'll present it to the classmates. The classmates will present it to them. And then, you know, this fishing pole design, then they'll go back and they'll design again. And this gets the students away from just learning what the scientific method is and to doing the scientific method. They'll do the science. They'll do the design. They'll do the redesign. They'll do the testing. They'll do the experimentation. They'll do the science. You've got to get the composite module. You're going to love the way you teach. The kids are going to love the way they learn. You're going to be asking for more. They're going to be asking for more. You got to get it. Thanks.